Welcome to another episode of The Collection, a series of videos where I look at the rocks and fossils that are contained within my own personal collection. And today we're taking a look at this wonderful chunk of volcanic material. So how do we know this is volcanic rock? Well, first we've got the lumps and folds that show it solidifying from a liquid material. Secondly, if we have a closer look, we can see the aerations in there of gas that was trapped when the rock went solid. So what you get is air bubbles and gas contained within the magma, and as the molten rock erupts out the ground and solidifies, this gas gets trapped. So those are two features of the rock itself, but perhaps the most obvious piece of evidence that it was volcanic was where I found this lump of rock, and that was on the side of a volcano in Iceland. I'm actually inside a side crater on the flank of the volcano, Skjaldbreiður, get it right eventually. Really weird experience being on the side of this small crater. I'll just show you around. Which is cool. These craters will form when the magma in the magma chamber underneath the volcano works its way up through the weaknesses in the side of the volcano, following little fractures in the rock. And weaknesses are up there, and they will work their way through to the sides of the volcano and eventually erupt outwards, forming things like this small crater on the side, and like that lump of rock behind me just there, a parasitic cone. And these will be little side eruptions based on the flank of the main part of the volcano. So it's it's just kind of cool. You can actually see Skjaldbreiður from Thingvellir. Now the volcano itself erupted around about 9,000 years ago and formed this absolutely fantastic shield volcano. It's the biggest shield volcano in Iceland and is pretty much a textbook example of a shield volcano. So what do I mean by shield volcano? So in the case of Skjaldbreiður, it was a small fissure that erupted for an extensive amount of time. Now this means that the volcano is a type of eruption called an effusive volcano. So an effusive eruption is fairly slow pace and is not as explosive as, say, the 2010 eruptions of the Icelandic volcano Eyjafjallajökull that shut down airspace across much of Europe and a good portion of North Atlantic. Skjaldbreiður's eruption was slower pace and was much more of a continuous lava flow. The lava itself covered an area of approximately 20 square kilometres, some of it heading north towards the ice cap now known as Þórðarjökull, most of it heading south to what will become Thingvellir, and actually forms the base of the Lake Thingvellir. You can actually see, if you wander around Thingvellir, you can actually see the remains of the ripples left in the lava as it had solidified. Now, over the 9,000 years, the rift valley that forms the Thingvellir has opened up, and you end up with these massive cracks and fissures across the landscape, creating just this absolute dramatic landscape that the early Icelanders must have been quite impressed by, because they decided to make this place their home for their parliament, the Althing, the world's longest continuous running parliament. As for this gorgeous piece of rock, I picked it up on the north flank of the old volcano. Whilst I was driving around, I got a chance to stop off and visit the site. I didn't go all the way up the volcano. I wasn't really prepared for a full hike, and the volcano is over 1,000 metres high. Did get a chance to visit some of the parasitic cones that are on the side, and it was just a fantastic experience. The volcano itself is fairly isolated. The only way to get to it is via what are known as the F roads, which are basically dirt and gravel tracks that crisscross the interior of Iceland, and are only open during the brief summer months. So you often have the place to yourself. In fact, I only passed one other car in about 4 hours of the time I was driving around there. For me personally, this humble little lump of rock represents a fantastic day full of memories, but also is a connection to the past of a volcanic eruption that occurred 9,000 years ago at the end of the last ice age.